Hey everyone, hope you are doing well. Today I'm going to teach you the proof of sine of x differentiated. So sine of x differentiated is cos of x, not to spoil the video, but I've often used that in some of my differentiation videos. And I feel like that's just taken as a given when you're differentiating, especially at, most levels, unless they ask you to do this specifically. So I suppose it's in the same sense that once you have other proofs or theorems, you can kind of use them in other proofs, or you can use them day to day because they're kind of a given. But I thought, as best not to be a cop-out, I will actually show you how we prove that sine of x differentiated is cos of x. So I'm going to go through the whole process, this part, and if it looks confusing, it really isn't. A lot of these proofs look more confusing than they are. Like, I've literally used like 3 principles or 3 theorems, and the rest of it is just rearranging. So, it is really simple, it's really straightforward, and I'm going to explain every step along the way and make it just like idiot proof. Not that you're an idiot, but just like, make it nice and simple, and you should understand all of it by the end. I guess one nuance or preface I should say is that we use things like differentiation from first principles, the sine addition function, the special trigonometric limit. So when you're doing proofs or day to day, you don't need to prove everything you're doing. Like, you don't need to prove, when you're doing 1 + 1 is 2, or you don't need to, I mean, maybe not the best example, but you don't need to prove all this stuff. You take a lot of stuff for granted. So I will reference what I'm using at each step, and maybe I'll pop something up about it. Maybe I won't. I don't want to digress by going into another theorem or another proof. So all these steps you can kind of use, and you don't have to, as far as I'm aware, explain them for this proof. So it's good to understand them, maybe where they come from, but you don't, or I'm not going to go into deep detail about each of these. I can do it in a separate video if you want to leave a comment or question, but I'm just going to reference them and explain how we do the proof. So I'm not going to, digress, as it were. I think because otherwise we'll go off track a bit. So that's a preface. So let's get into the proof. So what we want to do is we want to let f of x basically mean our function of x equal to sine of x. Simple, straightforward. Okay, that's what we're doing. We're defining f of x. That's our first step. Now from here, we're going to take the differentiation with first principles, I guess, theorem. I should call it a theorem. And I'm just writing it out. This is just the theorem, or whatever you want to call it. And that's when you differentiate from first principles, f dash of x is equal to the limit as h tends to 0 of function of x plus h minus f of x over h. And I think it comes from, when you have like 2 points on a curve, if you want to find the gradient, they won't be the same, but if they get closer and closer, it'll be so small that they are basically the same. Don't quote me on that, but I might pop something up. But that is differentiation from first principles. That is just a generic, I guess, equation that you use. Now from here, all we do is sub our thing into the equation. Nice and simple. We've probably done that in maths before. So f dash of x, f of x differentiated, is equal to the limit as h is equal to 0. This is the same, or this bit. And we just sub in our f of x is equal to sine of x here. So it's sine of x plus h minus sine of x over h. And if we take our function of x, well, it's sine of x plus h. So you would do it as x plus h. I feel like I found that a bit not intuitive when I first looked at it, but if you look at it enough, it kind of makes sense. That's f of x, so that's sine of x over h. Nice and simple. That's probably the hardest part, to be honest, of this proof. So now we just basically need to rearrange, simplify, and we get our cos of x. SAF, sine addition formula, or at least I hope that's what it is. Sine of a plus b is equal to sine of a times cos of b plus cos of a times sine of b. These are kind of things you learn, I think, in GCSE level, potentially. And they're these, addition formulas, and it's for substituting sine and cos. Now, I'm trying to think where they originated from, probably from triangles. But I will pop that up. I'll pop up a little bit of information about that. But we're basically going to use this formula. So where do we have a sine of a plus b? Well, we've got a sine of x plus h. That's pretty similar, pretty convenient. So we would just treat the x as the a and the h as the b. And we've got the limit as h tends to 0 of sine of x times cos of h plus cos of x times sine of h minus sine of x. So that's all we've done. We've just used that sine addition formula, and we've taken this and I guess expanded into here, okay? We've got minus sine of x and h. That's all we've done. Nice and simple. Now here, I put rearranged terms. And you know what? This is almost kind of comical, really, because we're just moving this to here and this to here. So we're grouping the sine of x's together. So we move this to here and this to here. That's all we've done. We've literally just rewritten that simple way, okay? So now we're going to, it is kind of a given, but I think the limit of this is the same as the limit of the two parts added together. So we can separate it in a sense. So the limit as h tends to 0 of this is the same as, because, we're separating it, but it's still over h. So it's still the same thing. We're just rewriting it. So we basically split over the h's because we want to split these terms because it's going to be easier for us to effectively get rid of or, rearrange. So we take this part here and we take sine of x, because this has sine of x in both these terms, sine of x times cos of h minus 1, because we've taken a factor of sine of x out of this part and it's over h, plus we've just kept this the same, but we've separated it, but they're still both over h. So that, that's a rule. It's just, hopefully you can see that's the same thing. They're still both over h. We just separated them and taken a sine of x out on the left-hand side. So the next thing we've done is taken out the sine of x and cos of x. And we've taken it out of the limit as h tends to 0. And we've done that because, h is changing, it's tending to 0. It's really irrelevant for sine of x because it doesn't have h in it. So it's basically treated as a constant for the purposes of this, if that makes sense. So just to reiterate, as h is tending to 0, sine of x is like, I don't care, I don't have an h, it doesn't affect me. So we can take the sine of x out, and then it's just timesing what's left in here as the limit as h tends to 0 because of h minus 1 over h, plus, we've kind of separated these into two limit things. The cos of x here is a constant. We're treating it as a constant because it doesn't change as h tends to 0. The limit of h tends to 0 of sine of h over h. We've basically taken them out as factors, okay? They're multiplied it, but we can take them out because they're not affected by the limit as h tends to 0. Okay, now I think I have to move the camera down a bit and I'll show you the last step. We're pretty much done. Okay, so I don't know if you can see me, but I'm on my knees now. I'm on my knees for money and maths. So next we just need to use these special trigonometric limits. So the limit as h10, so these are kind of those sort of a given things that I mentioned earlier. Use special trigonometric limits, and these are things that have been proven, and I think they've been proven geometrically. I can't remember, but maybe I'll pop them up. But we can kind of take these as a given because, normally, sine of, I think the sine of 0 is 1 maybe, and it's 1 divided by 0. Like, they don't work as h tends to 0. So some smart person basically worked out, you know, what they're equivalent to, or how they're quite, you know, someone someone a lot smarter than myself, and they basically helped us understand that the limit as h tends to 0 as cos of h minus 1 over h is equal to 0, and the limit as h tends to 0 of sin of h over h is equal to 1. And that's convenient because that's exactly what we have here and here. So looking at that, we have f dash of x is equal to the sine of x we took out times the cos of h minus 1, which is now 0. So that's going to be 0 times sine of x, which is 0. And then we've got cos of x times this, which is 1. So this becomes 0. Times something by 0, it becomes 0. Although at this point, you know, I'm starting to question everything. So it does still apply though. So that's 0, and that's going to be cos of x times 1. So f dash of x is equal to cos of x, and that's how we get there. So if you're lazy and you kind of just wanted to see the whole thing, I'll step out the way for a sec, and hopefully you can see the whole thing. And I feel like this is a good way to end, but I will quickly just explain what we did in case anyone's confused, okay? So taking it from the top. So just running through it a bit quicker now. We have f of x is equal to sine of x. That is our defined function. From there, we use differentiation from first principles. We sub in our function, then we use the sine addition formula to expand this part, okay? Then what we do is we swap these two in their place. So swap them for the sake of convenience, because it's going to help us further down the line. Then we're taking a factor of sine of x out of this part, and this is fine. And we're separating these because the limit of these two is the same of the limit of it as one thing. You know, you can separate things if they're over the same number, or in this case h, and then from there we take out the sine of x and cos of x because they are effectively constants as h tends to 0. That's because they don't have h in them. And from here we need to use the special trigonometric limits. Now I think these were worked out with geometry, it doesn't really matter. Anyway, so for example, like cos of h, like these things are weird because you have 0 on the bottom. So it's like, how are you going to divide by 0? So we've had a smart person tell us that cos of h minus 1 over h is 0 as h tends to 0, and this one's 1. Sub them into our formula. You know, this is 0, so it's 0. This is 1 times cos of x, and that's it. So hopefully that makes sense. Hopefully it was clear. If you do have any comments or questions, let me know down below. But yeah, if you made it this far, I appreciate it. I'm trying to get my watch time up, so that is good. And yeah, thank you for watching. Best of luck with your maths. If you have comments or questions, you can let me know. Can't promise I can help, I can try. And yeah, best of luck with your maths.